So this page gives you a good summary of these 4 different quadrilateral. So how do I prove that a quadrilateral is actually a parallelogram? As long as you have quadrilateral with 2 parallel sides, they are parallelogram. Same thing, 2 pairs of equal sides, they are also considered parallelogram. 2 pairs of equal opposite angles, you can assume that it is a parallelogram. Next, a pair of equal and parallel sides. So as long as one pair of equal sides and they are parallel, you can assume that it is a parallelogram, or you can conclude that it's a parallelogram. Next, rectangle. Rectangle is a stricter kind of a parallelogram. The strictness comes when there is a right angle involved. So all the angles are for right angles. We can assume that we can conclude that it is actually a rectangle. Or we have a parallelogram. So any one of the 4 property of a parallelogram, on top of that, it must have at least one right angle, and therefore it is a rectangle. Okay. Rhombus are also a form of parallelogram with stricter criteria. So on top of that, as long as you have 4 equal sides, they are rhombus, or parallelogram with equal adjacent sides. So the difference between on top of being a parallelogram, rhombus must have equal sides. Square is the strictest kind of rhombus, rectangle, or a parallelogram. So as long as you have 4 equal sides and 4 right angles, they are square. Or any rectangle that has equal adjacent sides. So adjacent sides means sides that are beside one another. These are adjacent sides. So if they are equal, we can conclude that they are square. So must be rectangle. So you must follow the criteria of a rectangle. On top of that, it must have adjacent side. Next, we also say that a rhombus with one right angle, they are also called a square. Okay, so these are different criteria to prove certain kind of quadrilateral. So let us try to do some example on it. Example 5. Example 5, first they ask you to prove that triangle ABC and CDA is a right angle triangle. They are congruent triangle. So you can pause this video and actually attempt to do it. Okay. Now, I would like to go through. I hope you have paused the video. Now, part 1. How to prove that triangle ABC is congruent to triangle CDA. Okay, highlighting the triangle. I like to highlight triangle so that I can see it clearly. Okay, also we like to look at the information given to us. So we know that ABCD is a quadrilateral with AD parallel to BC and BC equals to AD. Okay, so we can use BC equals to AD as one of our, because we have BC and DA. Okay, so we can say that BC equals to DA. This is given. Other than that, we can also say that angle BCA equals to angle, remember it goes according to the sequence, so it is BCA, so we follow the sequence. It is angle DAC. And what is it? This angle and this angle. What are they? They are actually alternate angles. Okay, because of the parallel lines. On top of that, if you realize, they both share the same length, and the same length that they share is actually AC. So if I call it AC in one of the triangle, the other triangle would be CA. Okay, so do write down AC equals to CA because it's a common length, side, common side. So with that, we have side, included angle, and side. Okay, side, included angle, and side, you can prove that this ABC is congruent to CDA because of SAS. Okay. Next, part 2. Prove that ABCD is parallelogram. So first, BC equals to AD. This is given. And they are parallel. BC is parallel to AD, also given. Take a look at parallelogram. Let us go to parallelogram. As long as they have, take a look at this. One pair of equal sides. So this is equal. And they are parallel. So same thing. Equal and parallel opposite sides. We have equal and parallel opposite sides in this question, which is these two lengths, BC and AD. Since quadrilateral ABCD has one pair of equal and parallel opposite sides. ABCD is a parallelogram. Okay, that's it. Now, next question. You might want to pause this video again and attempt this question. Okay, so let us go through this question together. I hope you have done this question. This question asks for, this question have introduction of ABCD is a quadrilateral. So we are looking at the whole figure ABCD. PQRS are midpoints of ABCD. Midpoints of AB, BC, CD, and DA, respectively. So prove that PQRS is a parallelogram. So we are actually looking at this. Okay. So, like they say there is a midpoint involved in this. So since it is midpoint PQRS, we might need to consider midpoint theorem in this case. So let us take a look at how to solve this question. Let us focus on this triangle. Okay, triangle BCD and triangle QCR. So let me erase the blue color lines away. These two triangles are what we focus on. Okay, so which means we are focusing on point Q and point R. Now take a look at this. How do we go about doing this? Is that we list them down since Q and R are midpoints of BC and DC respectively. We can say that QR is parallel to BD. Okay? Next. Now we take a look at this small triangle. So I'm going to erase up the triangle. So you know that this is midpoint theorem. Okay, so since they are midpoints and therefore we can conclude that the two lines QR and BD are actually parallel to each other. Now next, what do I want you to take a look at? Now I need you to take a look at these two triangles. We are looking at APS and we are also looking at ABD. Okay, same thing. We are looking at these 2 points P and S. Since P and S are midpoints of AB and AD respectively, we can say that PS is parallel to BD. Okay. On top of being parallel, midpoint theorem, on top of being parallel, what can we say about the length of these lines? What can we say about the length of PS and what can we say about the length of QR? So on top of being parallel, we know that QR, sorry, I need to add this on, it's actually half of the length of BD. Okay, because midpoint theorem tells us that it's half. Okay, and PS is also half of the length of BD. So what can we conclude here? It's all midpoint theorem. What can we conclude here? We can conclude that since QR is parallel to BD and it is also parallel to PS, we can say that QR is parallel to PS. Next thing, we know that QR is half of BD and half of BD is also the length of PS. We can say that QR equals to PS. So take a look at the question. Let's take a look at the diagram itself. We are looking at QR and PS now. We know that they are parallel and we know that they are equal length. So using your using your property of parallelogram, we know that therefore PQRS is a parallelogram. Okay, because of the opposite equal sides, and this one is opposite parallel sides. Okay? So these two are the two sides that are opposite, parallel and equal. So therefore PQRS is a parallelogram. So that's all for 10.2.